Hi guys, welcome to highschoolmaths.co.uk. Today we're going to look at the 2019 National 5 Paper 1. So we're just going to crack on through this. If you do need to see any repetitions of the video, just pause it and rewind it. So given that f of x equals 5x cubed, evaluate f of negative 2. So a nice function question to start off with. I'm just going to copy the question down again. So we're looking to replace the x with the negative 2. So in that substitution, we've got 5 bracket. So basically, whatever with functions, whatever's in the bracket, we replace the x with the bracket. So 5 times negative 2 cubed. Negative 2 cubed, we do the power first. That's your order of operations. Negative 2 cubed is negative 8. That's negative 2 times negative 2 times negative 2. That gives you negative 40. And that's you finish for your 2 marks. Question 2, a little bit of fractions work. So 3 over 8 times 1 and 5/7. Okay, so first thing I'm going to do is make that second fraction top heavy, or improper. 1 times 7 is 7, add on to the top is 12 over 7. Denominator stays the same, and then it's top times top, bottom times bottom. Now, there's different ways of looking about this. At this stage, when you reach the multiplication stage, and you've got two single fractions, you could look to see if there's anything can simplify here. So we've got the 8 and the 12 are both in the 4 times table. So how many 4s fit into 12? That would be 3. How many 4s fit into 8? That would be 2. And then that makes the calculation a little bit easier. So 3 times 3 is 9, top times top, and bottom times bottom. 2 times 7 is 14. And because we've already completed the simplification step here, our final answer is fully simplified. Okay, question 3, expanding brackets. So get x plus 5 bracket 2x squared minus 7x minus 3. And we're just going to multiply the brackets. So we're going to start with the x term. X times 2x squared is 2x cubed. X times negative 7x is negative 7x squared. X times negative 3 is negative 3x. Moving underneath, we're going to multiply by the 5 now. So plus 5 times 2x is plus 10x squared. 5 times negative 7x would be negative 35x, and 5 times negative 3 would be negative 15. So we get 2 marks for multiplying out that line, and then we're collecting like terms. We've only got one cubed term, that's the 2x cubed. We've got the minus 7x squared here, and the plus 10x squared, so that's going to give us plus 3x squared, minus 3x minus 35x, minus 38x, and the minus 15 for our final number term. Okay, question 4. So what have we got here? We've got a sector of a circle. The radius of the circle is 30. So it's giving that information in the diagram. It's giving you the angle for the sector. It's 240. And it wants us to calculate the arc length. Okay, so arc length would be angle over 360 times pi d. Okay. And the angle in this case is 240 over 360 times pi. So we've got to use 3.14 for pi. That's what it tells us to do down here. And the diameter in this case would be 60. This is the radius. What we're looking to do, because this is non-calculator, is try and simplify. This fraction does simplify down to 2/3. So we end up with 2/3 times 3.14 times 60. And remember, when you're multiplying, you can do it in any order. So it's easiest to leave the 3.14, which is the most difficult part, to last here. So we're going to do 2/3 of 60 first. 60 divided by 3 is 20, times 2 is 40. So we end up with 40 times 3.14. And then that gives us 4 times 31.4. If we multiply by 10 first, now I'm just going to set a separate sum for that. 31.4 times 4. Keep this 1.9. 4 4s are 16, carry the 1. 4 1s are 4, add on the 1 is 5, and 4 3s are 12. So we end up with 125.6 centimeters for our arc length. Okay, good. Question 5. Midday temperatures recorded over 9-day period. Temperatures in degrees Celsius where calculate the median. Okay, so first thing I'm going to have to do is put these in order. So it looks like the lowest number we've got is 3. So 3, and then another 3. 4, and another 4. 5. A 7. Oh no, a 6. No, I missed that. A 6, then a 7. And a 9 and a 10. Okay, I think that's me got them all. Yep. So median and the semi-interquartile range for these temperatures. So the median, first of all, will be the middle number. Now we've got, what was it, 9-day period. So we've got 9 numbers, 4 numbers per half. That's 1, 2, 3, 4, 1, 2, 3, 4. And the number in the middle this time will be our median. So the median equals 5. So what we want, that's also our Q2 for the quartiles. So if we're looking for semi-interquartile range, we've got to have a Q1 and a Q3. So Q1, we should be able to fit in here, Q3. So Q1 is the middle of the lower half. So we've got 4 numbers in this lower half here. We're going to split that in the middle, and we're going to end up with 3.5 because it's halfway between the 3 and the 4. There's 2 numbers in each half. Same idea up at the top. So the middle of the top 4 group is going to be 8, halfway between 7 and 9. And then our semi-interquartile range. So we're looking interquartile. We're wanting the distance between the value between the Q3 and Q1. So it's Q3 minus Q1 all over 2 because it's semi-interquartile range. We've got 8 take away 3.5 divided by 2. That's 4.5 divided by 2. And you can write that in a variety of different ways. Don't leave a decimal within your final answer though, within your final fraction. So we could either write that as 9 over 4, or if we wanted to write it as decimal, 2.25. Either's fine. Okay, so moving down, we've got over the same 9-day period, the midday temperatures in Endok were also recorded. Median temperature was 8 degrees Celsius and semi-interquartile range was 1.5. So it's one of your comparison questions. So probably what we're looking for here is 2 valid statements. So I'm going to bullet point the first one. So we're going to look at the median temperature. The median is one of the measures of average. You can see our median to start off with was 5. It's now 8. So the median temperature, the average temperature, has increased. So that's what we're going to say now. We don't want to use the word median. We want to revert back to the standards, understandable English. So we want to call it as average and show that we understand that the median is a measure of average. So the average temperature in Endok was higher. And then a numerical comparison, 8 degrees is greater than 5 degrees, which is what we got for the median in part A. The second bullet point for the second mark is going to be looking at the semi-interquartile range, which is 1.5. So you can see our semi-interquartile range here was 2.25. The semi-interquartile range is a measure of range. We've got our range calculation, which you would have looked at back in first or second year. You've got semi-interquartile range, you've got standard deviation. All these things are different ways of measuring how spread out your values are. So we've got a bigger semi-interquartile range here. That means the first set of temperatures were more spread out. So if we want to compare the second set, then the second set were less spread out. So that's what we want to say. So we want the temperature in Endok was less spread out or less varied, since it's 1.5 degrees C is less than 2.25 degrees C. Again, a little numerical comparison to show that you know which things you're comparing. Okay. Question 6. So we've got a little graph here. Fuel consumption for the car is recorded. The scar graph shows the relationship between fuel consumption per litre and the engine size of the car. Okay, so we've got the graph there. Line of best fit has been drawn. Find the equation on the line of best fit. Okay, so we need 2 coordinates on the line. So let's pick our 2 coordinates first. So I'll say for our first coordinate, I'm going to use this one here because there's a dot right on one of the crossover points. So we've got, 1.5 and 14. So we don't really want to take a point somewhere here or somewhere in the middle of the box because that's going to be an estimation then where it's not going to be totally accurate. We want to pick one of the ones that crosses over one of the grid lines. So the line crosses over here. So we're picking 1.5 and 14. Going down the line, I want to pick another point across the grid line, and you can see there's one being marked out here, which is 3.5 and 8. Remember, your point that you choose needs to be on the line. It can't just be any of the random dots. We're looking for the equation of the line, so you've got to choose a point that lies on the line. Okay, so we're going to start off with this question. Find the equation line, define the gradient. So the gradient of this line is going to be your y2 minus y1 over x2 minus x1. And then we're just going through this process of popping in numbers. So remember, x1, y1, x2, y2. So we've got the y coordinates first. So I'm going to start with the top, 14 minus 8. And then, again, top take away bottom, 1.5 take away 3.5. That's quite nice. The decimals are going to cancel out each other there. So 14 take away is 6. 1.5 take away 3.5 is 2. Sorry, negative 2. And that gives us negative 3. Now, as you'd expect, the line was sloping down the way if we look at the graph. So we should get a negative gradient, and we have got a negative gradient. So we now need to try and figure out what the y-intercept is going to be. So we've not got a y-intercept from the graph, so we're going to have to figure that out. There's two different ways you can figure this out. What I am going to do here is I'll go for the y minus b method. So we've got y minus b equals m bracket x minus a. And rather than calculating the y-intercept, this will take care of that problem for us. So let's see, we've got y, so we want to take a coordinate for a and b values. We've got our gradient, so the coordinate could be either this one or this one. Not really any difference between picking them, so they're both positive. So I'm going to pick 1.5 and 14 for my a and b value. As y minus 14 equals m, which was negative 3, bracket x minus 1.5. And just going to simplify that. So y minus 14 equals negative 3x plus 4.5. And then I'm going to add 14 to both sides to get y equals negative 3x plus 14 to both sides, which gives it plus 18.5. Okay, now I did want, and this is a key part, I did want an equation in terms of f and e. So at that final stage, always double check that you have answered the question fully, particularly with these problem solving straight line questions. So the y-axis was, if we look at it, was a fuel consumption axis. So instead of having y, we've got f for fuel equals negative 3, and instead of having the x-axis, we've got the e-axis for the engine size, so negative 3e plus 18.5. And that is our final equation. Okay, we're then going to use that equation. So we've got this relationship between the fuel and the engine size. So it says a Mars car has an engine size of 1.1 litres. So it's given us the engine size is 1.1. So E is 1.1. Use your equation to find or to estimate how much fuel he would use. So negative 3 E, which is 1.1, plus 18.5. F equals, that's going to be negative 3.3 plus 18.5. And we're just doing 18.5 take away 3.3, which is 15.2. Okay. Next, area of a trapezium. so a change of subject is giving you the area of trapezium formula. So we want to rearrange the subject, rearrange the equation. So the subject of the formula is x. So let's start off. I'm going to copy this down so we've got some space to work. And first thing I want to do here is deal with this fraction. So if we're looking to balance the equation, opposite of halving something is doubling or timesing by 2. So I'm going to double both sides of the equation. So we get 2a equals h bracket x plus y. That already makes things a lot simpler looking. Now, we've still got the x within the bracket. So I'm going to have to try and move this h across first. So if I divide both sides of the equation by h, because h is multiplying here, if we divide both sides by h, that'll help us get the bracket on its own. Now, because the h is no longer multiplying the bracket, we don't need the bracket. So we can get the x on its own at the end by just taking away y from both sides. So 2a over h minus y equals x. And then we can flip that around just to make it a wee bit neater looking. 2a over h minus y, and that's us finished. Okay. John bought 7 bags of cement, 3 bags of gravel. Write an equation. So 7 cement, let's say 7c plus 3g equals 215 then. So that the 7 bags plus the cement, 3 bags of gravel weighs 215. Fairly straightforward equation. Let's scroll down. We're going to make another equation here. So we've got 5 bags of cement plus 4 bags of gravel equals 200. Okay, so nice easy 2 marks there. And this is leading into simultaneous equations. You can see your standard kind of form an equation, and then solve to find the weight of one of the bags or both bags. So let's write our equations down here. 7c plus 3g is 215. And 5c plus 4g equals 200. Okay, so I'll call this equation 1 and 2. And none of the coefficients of the c or g terms match up here, so we're going to have to scale them. Probably the easier way to do that here is just to multiply by 4 for the top and 3 for the bottom, so we end up with 12 g's. So let's go for that. I'm just going to move this over. Okay, so if we multiply the top one by 4, we get 28c plus 12g equals 860. And the second equation, if we multiply it by 3, we get 15c plus 12g equals 600. Okay, so I'm going to call them 3 and 4. We've scaled both the equations. They're new equations. We want to eliminate these two g terms. So I'm going to subtract them. If we do 12 take away 12, then that will cancel or eliminate them from the equation. So we're going to do 3 take away 4 because 3 is the set of equations that has the bigger numbers. So 28 take away 15 is 13c. 12 take away 12 does in fact cancel out. 860 take away 600 is 260. You can see it's actually going to cancel down. If we divide by 13, it's going to give us a nice number. So c equals 20. Now, we have to, that's the weight of one bag of cement. We want to then figure out the weight of one bag of gravel. So we're going to use this in one of our original equations. And that's the key point. We'll always go back to your original equations. They're going to be smaller, nicer to work with. So I'm going to pick equation 2. And that's 5c plus 4g equals 200. Okay, and we now know c is 20. So it's 5 times 20 plus 4g equals 200. 5 times 20 is 100 plus 4g equals 200. Take 100 off both sides and we end up with 4g equals 100 and g equals divided by 4, 25. Put a little statement at the end, so cement is going to be 20 kilograms per bag and gravel is 25 kilograms per bag. Okay, that's us finished. Question 9, little parabolas question. So it's giving you the turning point, write down the equation of the axis of symmetry. Okay, so the axis of symmetry goes straight through the middle of the graph, so we've got a line going straight down through the middle, essentially. Well, that's a thick line. Let's change that. Okay, so we've got a line going straight down the middle there, and that's our axis of symmetry. It's a vertical line. Vertical line always has an equation of x equals, cuts through the x-axis, and the x-coordinates are always going to be the same on this line. We're always 4 along. So 4, 0, 4, 1, 4, 2, 4, 2, blah, 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 all the way up to 420. So the equation of that graph would be x equals 4. Oh, sorry, the equation of that graph, the equation of the axis of symmetry of this graph would be x equals 4. It then says, it asks us to identify the values of a and b. Okay, so here, a is going to be the x-coordinate, the coordinate of the turning point, and this is your completed square form. A little bit unusual because it is a sad face. You've got this upside down parabola, which is why we've got the negative x squared term within our completed square form, but the x-coordinate still comes in the bracket. The x-coordinate here is 4 for our turning point, so if we put that back into the bracket into its factor, we've got x plus a, that's going to be x minus 4 to give us x equals 4 for our value. So the a value would be minus 4. Easy way to remember that is just the bit in the bracket always changes. Outside the bracket, we've got the b term. The b term is your y coordinate, and that's just going to be 20 here. So b equals 20. Okay, so the bit outside the bracket always stays the same. Sign for the sign. Let's look at the next question. Okay, we've got a little vectors question. Express PQ in component form. So PQ is this line here. We've got PR plus PR and RQ. So it's wanting us to look at a vector path here. To get from P to Q, using what we know, we've got to go from P to R, then R to Q. So, well, I can't, that's not right. So we're going from P to R, so PR plus R to Q. And if we write that down in terms of its vectors, components, we get 6, negative 4 for PR plus negative 1 not over 8, negative 1, 8. And that equals 6 add negative 1 is 5, negative 4 add 8 is 4, so we've got 5, 4. So the vector PQ equals 5, 4. Okay, so it's saying M is the midpoint of PR, so M is the midpoint of this line. Express MQ in component form. So it wants us to get from M to Q, and we've already gone from P to Q. So if we want to get from M to Q, then what we've got to do is realize that this from M to R is a half of PR. So if we say, start off by saying, okay, we want to go from M to R plus R to Q. But if we think about that, M to R is a half of PR because we don't know what MR is, but we do know what PR is. So it's a half of PR plus RQ, which we do know. Half of PR, so again, we're going to substitute the components in. So PR was 6, negative 4, and RQ was negative 1, 8. That gives us just half each value here for the X and Y components. So half of 6 is 3, half of negative 4 is negative 2. And we get 3, negative 2, and plus negative 1, 8. Again, add the X components. So 3 add negative 1 is 2, negative 2 add 8 is 6. So we get 2, 6 for our components for MQ. Okay. Question 11. Pam is designing a logo. She starts by drawing a regular pentagon. The vertices of the pentagon lie on the circumference of a circle with center O. We've got the diagram here. She then adds the sign as shown to the diagram. Okay. Calculate the size of angle OFB. Okay, looks like a little kind of geometry angle work here. So let's have a look at this diagram. So what have we got? We've got a regular pentagon. That means all the sides of the pentagon and all the angles within the pentagon are equal. So if we look at the center point, let's get some values plugged in here. So all these, if you look at the center point, it's going to be 360 divided by 5 for each of these 5 triangles. So each angle in here is going to be 72 degrees. We are looking to deal with angles. We're looking for the size of angle OFB. So we want to get the OFB. So this is what we're looking for here. This is our target. Most of the work's going to come within the diagram here. So if that's 72 degrees, then that leaves, this is a straight line, so that's got to be 108 degrees to make it 180 for these two angles, or these two corners. Now if you look at this, this is going from the center of the circle out to the circumference, same here. So both these lines from O to F and O to B are equal. They're both the radius, which means it's an isosceles triangle. So these two angles must be equal. So if we split this, if we 180 degrees in a triangle, 180, take away the 108 degrees, would be 72. We split that equally, that tells us there has to be 36 degrees here and 36 degrees here. So the angle we're looking for, OFB, is going to be 36 degrees. Okay, moving on. Express root 2 over root 40 as a fraction and with a rational denominator. Okay, so first thing I'm seeing here is they're both divisible by 2. They're both even, so I'm going to divide by root 2. That gives us root 1 over root 20. So simplify the fraction if we can first. Square root of 1 is 1, so we get 1 over root 20. Okay, so there's a few different ways we can approach this. It is really entirely up to you what you feel comfortable with. I already noticed that the root 20 on the bottom is simplifiable. So we get 1 over root 4 root 5. Square root of 4 is 2, so 1 over 2 root 5. You're going to have to do some kind of surge simplification for this root 20 at some stage. Now that we've got that this far, we've simplified the original question as much as possible. We want to rationalize that denominator. So we can multiply by the root 5 and the root 5. 1 times root 5 is 1 root 5, or root 5. 2 root 5 times root 5. Root 5 times root 5 is 5. 2 times 5 is 10. I'll write it as 2 times 5, just to give that extra line of working. So root 5 over 10. That does not simplify anymore. We've got a root term on top and a number term on bottom. There's no way we can simplify that. And we've got a rational denominator. So for this stage here, probably the trickiest part is multiplying the 2 root 5 by the root 5. So what we've got there for that part is 2 times root 5 times root 5. Root 5 times root 5 is root 25. So we're multiplying the root terms together. The square root of 25 is 5, so we end up with 2 times 5, which is 10. A little bit of working out of the side can help a lot there, just to make things a little bit easier. Okay, 13. We've got a little phase angle here, so part of the graph of y equals 3 cos x plus 45 is shown in the diagram. State the value of a. So we've got 2 coordinates we want to find. Let's see. So this is the cos graph. The cos graph has been shifted along 45 degrees to the left. So it's gone in this direction, 45 degrees. Okay, so the cos graph should start here. Now it's telling us the amplitude of the wave is 3. So the maximum value should be 3 and the minimum value would be minus 3. And the graph's not been transformed up or down vertically. So 3 and minus 3. Are our amplitudes and heights, maximum minimum points for the graph. Now, with the normal function, if we extend that, would go kind of something like that and start turning around and go back down like a normal cosine wave function. This point here would normally bear 0, this point would normally bear 90, and this point would normally bear 180. But the whole graph's been shifted 45 degrees backwards. So instead of this being 180, which would be the halfway point, it's now going to be 135. So that's our x coordinate, 135 degrees, and the y coordinate is negative 3 from the amplitude. Okay, that's your 2 marks. Solve the equation. You have fractional equation, so let's copy this down. X over 2 minus 1 equals 3 minus x over 5. Looks horrible. It looks like a nasty little equation, but if we deal with the fractions first, then we'll be able to solve this no bother. So let's look at the denominators, 2 and 5. If we look at the lowest common multiple of 2 and 5, that's 10. So we're going to multiply everything in this equation by 10. Now I'm just going to lay this out in full. So 10 times x over 2, so we'll multiply this one by 10, multiply that by 10, and multiply this side as well by 10. Okay, so every single term in that equation has been multiplied by 10, both sides multiplied by 10 to keep it balanced. Okay, if we've done this right, the fractions should cancel here. So 10 divided by 2 is 5, so 5x minus the 10. 10 divided by 5 is 2. And now we've just got an equation without any fractions that looks a lot simpler to solve. So 5x minus 10, that's an x, equals 6 minus 2x. If we take away 10 from both sides, sorry, add 10 to both sides, that gives us 16 minus 2x. And if we add 2x to both sides, we get 7x equals 16. And then divide by 7, we get 16 over 7. Isn't that a weird answer? Okay. So, key thing there really is deal with fractions first. If you do that, it turns it into a quite straightforward linear equation. We can just solve that using the balancing out method. Okay, question 15. Height of a ball. So it looks like another parabolas question. You can see the parabola shape here. So it's represented, and we've got a quadratic function there. So height after t seconds is given by the formula h equals. So height equals, after 2 seconds, we're just replacing, so t equals 2. That's what it's telling us there. This is the time after 2 seconds, the height after 2 seconds. So 12 times 2 minus 5 times 2 squared. This is using this equation here, but instead of writing the t's, we're writing the 2's. So 12 times 2 is 24. Remember, do the power first. Don't do 5 times 2. 2 squared first is 4, so 5 times 4. And we get 24 minus 20, so h would equal 4 meters. Was it meters? Yeah. Okay. So let's have a look at the part B for this. So it says the graph below represents h after relative to the cliff top after t seconds. So it's taken that same diagram but plotted on a mathematical kind of graph here. So the C is 17 millimeters below the cliff top. After how many seconds will the ball hit the C? Okay, a little bit tricky on this one. So let's say it's asking us when it'll hit the C. Well, H represented the height of the ball relative to the cliff top. Okay, so here's your cliff top. This is your cliff top at 0. So the height would be then, the height of the ball would be negative 17. So if we look at our equation, it was H equals 12t minus 5t squared. And it's asking us to find the time in this part. So how many seconds? So that's time. Okay, it says the height is negative 17. It's 17 below, and you can see from the graph it's identified that that's your h value. So we've got this equation which we have to try and solve. Okay, now it is a quadratic equation. Highest power in this equation is the t squared. So to solve a quadratic equation, we've got to make this equation equal to 0. To do that, I'm going to bring everything over to the left-hand side. So I'm going to add 5t squared to both sides. I'm going to take away 12t. I'm going to leave the minus 17 where it was on this side, and that leaves 0 on this side. We then have to process the equation by factorizing. So the only thing that gives us 5t squared is 5t times t. We're looking to get 17 at the end. Fortunately, 17 is a prime number, so that makes it a little bit easier. The only thing we can use is 17 and 1. So if we put the 17 here and the 1 here, that gives us 17t and 5t. Multiplying these pairs together. We want a minus 12t in the middle, so we've got to have a minus 17 plus the 5, which means we want a minus 17 here to give us the minus 17t and a plus 1 here to give us the plus 5t. We now have our equation factorized. We can set each bracket equal to 0 and solve. So 5t equals 17 for the left-hand equation, and t equals 17 over 5. Or for the right-hand equation, t equals negative 1. Now, we're not looking for two answers here, so the final mark here is for recognizing that if we're talking about time, the time it takes for that ball to drop or ball to hit the C, it can be a negative number. Okay, so the time equals 17 over 5, since t must be greater than 0. Okay, so that's our final answer there, not that one. Okay, please don't scrub this all out when you get in the exam. Just a line through it will be fine. Okay, good. And that looks like the last question. Okay, all done. Great, that was 2019, paper 1 question. Have a look through more of the videos for the paper 2 solutions and other years past papers, as well as some other tutorial lessons. Thanks for tuning in, and please hit the like button and subscribe if you like the video. See you later.